Another misconception is that water is the best absorber of microwaves in cooking process. Well, water is very strong with surface coupling. Now, we have done years of product development with vegetable oils, especially soybean oil, to process greases and lubricants with microwave. And surprisingly, oil, although it doesn't have a strong surface coupling, it has deeper penetration with the microwave and actually heats better. So we're going to run a couple of tests here quickly. One, we're going to test the water in 4 minutes, and then test oil alone in 4 minutes, and then test oil and water next to each other, just to make a point here. So here's the quantity of water in a container, and we have an identical one for the oil. So the temperature initially is about 15 degrees, and we start the microwave, and I will advance it so we don't have to wait 2 minutes for this to run. As we are advancing that, we come here until it's ready to wrap it up. And now if we test the temperature, first we test it quickly, mix it, and then test the temperature. Temperature is 56 degrees centigrade in 2 minutes. Now we go and run it again for 2 more minutes. And again, we advance it quickly. And now the temperature is 88 degrees. So we're going to do the same thing with oil here. And this time, channel 2 is going to show the temperature for the oil. Originally, it is at 14 degrees, 14.5 degrees. And we'll put it in the microwave and run it. And now the temperature is 67 degrees in 2 minutes, which is considerably higher than what we did with the water. Now we're going to test it again for 2 minutes. And I think we'll make the point that the change in temperature is dramatically different for the vegetable oil versus water. These are same quantity, same mass of the liquids, same container, and same microwave. And now the temperature is actually 117 degrees centigrade, which is about 40 degrees higher. Now we're going to put these two next to each other and run it for 5 minutes to show what happens, which is counterintuitive. So we test these, we run them. We mix the water and the oil and use their respective fiber optic temperature sensors that very quickly tells the temperature. And here's the surprise that water is at 82 degrees and oil at 63 degrees, which we saw earlier that the oil heated much faster. So sometimes we have products like broth here that is a mixture of oil and water. This is what happens now. We've got the two products mixed. So you can imagine water boils at 100 degrees, oil can boil at much higher. And in some cases, especially in this case, because there is no actual mixing taking place, we could have nucleate the water molecules under the oil. So when we want to test this, as soon as the mixing begins, the water will boil because the temperature now is over 100 degrees, and you can see how much foaming takes place. This could be actually dangerous at home because it could spill over, and we can see the temperature is over 100 degrees here. So there are a lot of different synergies that take place when we heat products. And luckily, microwaves allow us to lock into molecules of the specific product. In fact, at some point, we should easily be able to have selective reaction within vessels by targeting specific products. Here's when we were heating the oil, we took some infrared pictures of them. You can see at 22 degrees, everything is cooler. But even when we heat it up to 141 degrees, there are a certain amount of the fatty acids within the triglycerides, the saturated versus unsaturated fats that are still not completely melted. These all help once we understand it to design a system that will be useful for all sorts of applications. We also know that some vegetables, if they have water in them, once you put them in the water would couple faster and gets hotter faster.